Welcome to my presentation. I am Nishu Chowdhury. Today I am going to represent one of my research work, and the name of this work is Pneumonia States Analyzed Through Image Processing. Paper ID 37660. These are the contents of my presentation. Introduction. First of all, I want to discuss some basic terms which are used in this research. What is pneumonia? Infection that inflames the ear cells in one or both lungs. The ear cells may fill with fluid, causing cough, fever, and difficulty breathing. Here I provide an example of chest X-ray, and here we see the shadow of pneumonia. By seeing the shadow of pneumonia, a physician can confirm a chest X-ray has pneumonia or not. In this research, I classified the stages of pneumonia into two classes: mild pneumonia and severe pneumonia. Mild pneumonia has less shadow, and in severe pneumonia, there is a very big shadow. Now let's move on ensemble method. When we use one deep learning and machine learning method, then sometimes it provides us some misinformation. So to tackle this problem or to handle this problem, we can aggregate the result of multiple machine learning or deep learning model together to produce our final result. In this way, the model accuracy is also improved. So in this research, I use ensemble method to classify a chest X-ray has pneumonia and not. There are three types of ensemble method: averaging, mass voting, and weighted average. Here I provide an example of ensemble averaging method. Suppose we have two classifiers, DenseNet201 and ResNet50V2, two transfer learning model, and we have two class 0 denoted with pneumonia not, and class 1 denoted for pneumonia yes. And DenseNet 201 suppose provide me zero point 0.2 for class 0 and zero point 0.8 for class 1, and ResNet 50V2 provide me zero point 0.5 for class 0 and zero point 0.5 for class 1. So we are getting the highest probability value zero point 0.5 for class 1. So our result will be 1. So in this way, we just classify a chest X-ray has pneumonia or not. When a chest X-ray is classified as pneumonia, then we measure the severity of the disease with image processing technique. Here we use different types of image processing algorithm. Morphological opening, thresholding, and contour detections algorithms are applied to measure the severity of the disease. Morphological opening operation. Morphological operations actually involved with image shape and size. And opening operation actually help us to remove the noises from the image. Noise means a small or fault information on the image. When an image contains noise, then it may lead us wrong informations that our models will also lead with misinformation. So to remove these types of noise and to um, improve the accuracy of our system, we are applied means we apply different types of opening operations on the input image. And when we use input opening operations on the input image, it removes noise from the images, and it provides me a very good view of lung portion on from the chest X-ray, and it also provides me a very clear shape and size of the object. Thresholding. It is a process to convert a grayscale image into binary image. It is helpful to object detection. So, I mean, it's very helpful for image processing. I mean, there are two advantages of thresholding operations. One of the is the it also improves the image computation time. Means it needs a less computation time for processing, and the image contains only white and black pixels, and it's also helpful for object detection. And when we apply the thresholding operation on the image, we are seeing the lung portion is very clear from the in this chest X-ray. Now we will apply contour detections approaches on the image processing. Contour detections approach actually help us to find the boundaries from the object. And when we apply this contour detections approach, we found this boundary at this contour area, contour and the left lung and right lung chest is right lung. Are separated from this chest X-ray by using this contour detections algorithm. Now let's introduce with bounding box function. Bounding box functions actually a one rectangle area, and this rectangle area actually used on the image to apply a specific mathematical calculation or to apply any calculation on the images for this area. Here we use two bounding box function, and because we want to calculate the total number of white pixels on this bounding box area, and by calculating this number of total white pixels, we just subtract this number from the total number of white pixels in the lung portion. In this way we'll get a actual number of white pixels which actually consists in the lung portion. So, what is the meaning of pneumonia classification with ensemble learning and stage analyzed through image processing? Actually, in this research, I used ensemble method to classify a chest X-ray has pneumonia or not. When a chest X-ray is classified, I means when a chest X-ray is classified as pneumonia, then we measure the severity of the disease through image processing algorithm. And why is it important? This methodology is very important because to get proper treatment, we have to know the stage of the pneumonia. Objective: to classify chest X-ray as pneumonia or normal with ensemble model and DenseNet 50 to DenseNet 201 and ResNet 50 model. After that, apply image processing algorithms to measure the severity of the disease. Motivation: to get proper treatment of pneumonia, we have to know the stage of means we have to know the stage or condition of the pneumonia. So it's very important to know the stage of pneumonia. Methodology: this research works in two parts: pneumonia classification and assessing the severity of the disease. First of all, I would like to discuss about pneumonia classification. In this task, first of all, I collect a dataset. The name of the dataset is chest X-ray images dataset, Paul Mooney chest X-ray dataset, and it has two samples: pneumonia samples and normal samples, and the datasets contain 5875 images. So before process it, we have to perform some pre-processing step. First of all, we remove the duplicate images from there, and in this way we just remove the biasness of the system, and we resize the image into 224 by 224 and convert the image into grayscale image. In this way we just reduce the computation time of the processing. So this is the flowchart of my recommended model dataset. Split the dataset as trained, traced, and valid, and apply augmentation approach. So what is augmentation? Actually, augmentation process creates different angle image from a particular image. So the main advantage of augmentation, when we apply augmentation, it increases our data size, dataset. I means it in then. mm it also helpful, I means it helps us our model to recognize any image from any angle. So it is the main advantage of augmentation process. After that, we apply ResNet50V2 and DenseNet201 transfer learning model, and we ensemble those models with averaging approach, and after that we classify the chest X-ray as pneumonia and normal. So when a chest X-ray is classified as pneumonia, then now and after that we have to assess the severity of the disease. According to American Thoracic Society and Infectious Disease Society of America, mild pneumonia has 50% to 60% white shadow, and in severe pneumonia, it has more than 60% white shadow. So, I mean, to measure the severity of the disease, first we do the following process. First of all, we collect the input image, then apply opening operation, after that thresholding operation on there, and finally we did contour detections approaches on the image, and in this way we just separated left lung and right lung portion from the image. And after that and now we have to calculate the total number of black pixel and white pixels on the lung portion. But in the means here we get means here we separated left lung and right lung portion. Now we have to calculate the percentage of white pixel and black pixel, but in this image there are some white pixels that are not the portion of lung portion, so we have to subtract this number of white pixels from the image, from the total number of white pixels. So here we use two boundary react function, and boundary react functions actually help us to calculate total number of white pixels on this bounding area. So in this way, by our subtracting this total number of white pixels from the total number of white pixels on the images, we calculate the actual percentage of black and white portion only in lung portion. And when the percentage of white pixels is more than 60%, then we will say the severe effect is severe pneumonia, otherwise it is a mild pneumonia. So this is the architectures of my whole model. First of all, we provide the input image, then our my input image goes through a model, and when means, and then it classify pneumonia and normal. And when the case is pneumonia, then we provide a input image. I means then we apply opening operation, thresholding operation, contour detections approaches on the image, and in this way we just separated left lung and right lung portion from the image. And we now calculate the white pixel and black pixels from those images, and find the percentage of the images. And when the percentage is more than 60%, then we say the case is severe, otherwise mild. Results and discussion. To measure the performance of the system, here we apply two approaches. First, measure the performance of the classifications approach, and in the second schema, and in the second case, we measure the performance of the severity of the disease. So here I just represent performance analysis of DenseNet 201 model. Here we see two lines, orange color line and the blue color line. Orange line is used for validation accuracy and blue line is used for train accuracy. And the model performance actually depends on to the validation accuracy. If a model has a very good a good number of validation accuracy rather than train accuracy, then we can say that the model has a means that the model performs well. So here we are seeing that a good number of validation accuracy and minimum number of validation loss. And in this diagram we are seeing that the ResNet50V2 also showing a good number of validation accuracy and a minimum number of loss. And this is the final uh, and this is the final result or accuracy or loss curve of my final model. And we see that there is a good number of validation accuracy and a very minimum number of validation loss. So we can say that our model is more accurate and precise to predict a specific disease, to predict a specific, I mean, to predict a chest x-ray has pneumonia or not. And now in this phase we will just measure the performance of my severity analysis. So here I provide three example. First of all, sample 1, here white pixel denote with W and the black pixel denote with B. So in this case, we are seeing that left lung portion has white pixel 43%, and in the right lung portion white pixel is 46%. Then we can say that left lung and right lung is normal. And in the sample 2, we are seeing the left lung has 70% white pixel and in right lung 51% white pixels. And so we can say that lung is severe and the right lung is mild affected. And in sample chip, we are seeing that left lung is 55% and right lung is 77%. So we can say that left lung is mild and right lung is severe affected. So this is the comparison of the existing work and my research work. Here we see that the another thing, from this finding or from this analysis we can say that our finding is also aligned with the statement of American Thoracic Society or Infectious Disease Society of America. And now I would like to compare my approach and the current means my approach and the existing work. And here we see that the most of the work is actually based on pneumonia classification, and they use different types of machine learning, deep learning, and image processing approaches. But I use a new approach to measure the severity of the disease, or to measure the severity of the pneumonia. And this is the main novelty and this is the main objective of my work. Conclusion: this study developed a model using image processing to determine pneumonia stages. The experiment results were successful, and this work shows promise for future use in pneumonia detection and medical diagnostic. And future work in the future, a dataset will be designed for mild and severe cases to diagnose the stages more smoothly. These are the references of my work. Thank you.